Hello again. For this video we're going to demonstrate how to rationalize denominators. We have a couple examples here of radicals with a fraction underneath them, which violates rule number 2, which means we have to rewrite this as the square root of 16 over the square root of 81. That fixes rule number 2. But now we have rule number 3 here, which is no radicals in the denominator. Well, it turns out that both of these can be simplified, so I can rewrite this as the square root of 16, which is 4, over the square root of 81, which is 9. So I can rewrite this whole thing as 4/9. Over here we got the same thing. Rewrite this as the square root of 5 over the square root of 49. Now the top cannot be simplified any, so we're just going to leave that as the square root of 5. But the bottom is a perfect square, and the square root of 49 is just 7. So the simplified version of this here is square root of 5 over 7. Notice that there's no square roots in the denominator of the final answer. So down here we have a square root of 5 in the denominator. It's not a perfect square, therefore we cannot just bring it outside as is. What we got to do is get rid of this radical, which is making the denominator irrational. We have to turn it into a rational number. Remember that radicals, let's say we have the square root of 2, can be undone by a second power. So the square root of 2 raised to the second is really the square root of 4, which is just 2. So you'll notice that the 2 on the outside cancels with the radical here, so these are reciprocal operators, leaving the 2 coming out. So the way we get that effect over here is to multiply the bottom number by itself. So we multiply by the square root of 5 on the bottom, but since this is a fraction, to keep it proportional, we have to multiply the top by the same amount. Now remember, there's a 1 out in front of here, so 4 times the 1 on the top gives you 4 times the square root of 5 on the top. And of course the bottom right here is going to give you the square root of 25, but the square root of 25 is just going to come out as 5. So the effect of multiplying these two right here is making the radical go away, and this ends up being your simplified number. Keep in mind that you cannot reduce the radical 5 here with the 5 here, because this is not really a 5. That's the square root of 5, which does not reduce with 5. So you cannot simplify irrational numbers with rational numbers. No simplifying allowed there. Example 2 here, next thing we want to do is to simplify this into square root of 3 over the square root of 50. Now square root of 3 cannot be reduced any further, but the square root of 50 can be reduced. We can call that the square root of 25 times 2, square root of 2, and the 3 is still in the numerator. And of course the square root of 25 is just 5 square root of 2. I still have the 3 on the top, but I still have a square root of 2, so the bottom has an irrational number. So how do you get rid of that? We're going to times it by itself. So you're going to times by the square root of 2 and the square root of 2, top and bottom. We don't have to multiply with this 5. The 5 is not a problem. It's the square root of 2 that's the problem. So just remember, when we multiply this, we get 3 times the square root of 2, which is 3 square root of 2. Now down here, I'm going to bring the 5 down, because the square root of 2 times the square root of 2 is really the square root of 4, which comes out as just 2. So this 2 that comes outside gets multiplied with the 5 that's already out in front. So 5 times 2 gives you a 10 underneath. So we have 3 square root of 2 all over 10. Number 3, we can break this 9 and the 75 out like we did up here with the 3 and the 50. However, on the 9 and the 75, they already have a common factor of 3, so I'm going to divide a 3 out of the top, and I'm going to divide a 3 out of the bottom, and we end up with 3 over, and 75 divided by 3 is 25, and the whole thing's under the radical. And then I will separate it into the square root of 3 over the square root of 25, and then the square root of 3 cannot be reduced any further. So square root of 3, well, it turns out that the square 25 here ends up being perfect square, so square root of 25 is just 5. So this ends up simplifying itself if we had just gone ahead and divided first. If you didn't divide first, you'd have to simplify the bottom a little bit more. Number 4 here, the numerator has no radical, but the bottom does. And again, the problem here is the square root of 2x, not the 3. So we're going to multiply by the square root of 2x here and the square root of 2x here. And the top is easy. 9 times square root of 2x is 9 square root of 2x over, bring the 3 down first, bring the 3 down, And then when we multiply these together, we end up with the square root of 4x squared, which comes out as just 2x. And that 2x will then be multiplied with the 3 here. So x, or the 3 times the 2, ends up giving you a 6x on the bottom. As far as we're concerned, as radicals go, this is simplified. However, the 9 and the 3 can be reduced, or sorry, the 9 and the 6 can be reduced. They both have a factor of 3, so I'm going to divide the top one by 3, 2 square root of 2x, and the bottom I'm going to divide by 3, and I'm back to 2x. So this ends up being your fully simplified answer over here.